Alright, now we will start to do the meshing of the laminar pipe. To do that, first locate the mesh in the toolbox, drag the mesh, keep this only on this cell, not here, not here, not here, and not here. Just drag it here and release it here. Now let's start the mesh. Let's now edit. You can see that this part here is only used for meshing only. And this part is only used for geometry. Thus, it has a heading of geometry, and thus it has a heading of meshing. If I had pressed the mesh anywhere else than this cell, let me talk about that at first. Okay, if I had selected mesh here, here, or here, anywhere else, I would have created a different mesh with different geometry. I would have to make the geometry differently. But if I click the mesh and drag it on this cell, I don't have to create another geometry. It will create a mesh on this existing geometry. So thus, it is important to drag the mesh only onto this cell, A2. All right. Now let's go to the meshing. So here's our meshing software already uploaded. The pipe. Now we will start doing meshing. So before that, make sure that your mesh setup is okay. Here is the physics reference as mechanical. I'm not doing a mechanical simulation here. I'm doing a CFD simulation. Mechanical simulation is for just those elements or shapes for those moment or force simulations, those types of things. But I'm not doing those things here. I'm just doing a fluid flow, which is a CFD simulation. So I have to change my physics preference to CFD. Let's change it to CFD. And here you go. Now I have to choose the methods. To choose a method, a specific method for the meshing, go to the mesh section, right click on it, insert method. Before that, and now we have to choose the whole body. Make sure the icon is selected as the body part and the body control plus B. If it is not, you can also press the keyboard control plus B to select the whole body. Now to select the whole body, just right click on the window and select all. So the whole body is selected now. Come here and apply and change the method here to tetrahedrons. So uh, those you just the method you just saw, I'm letting you see it again. Just select this first. So let's select all bodies. Go to the insert method, automatic, change the automatic. This you see, these are the methods I just gone through in the previous video. The automatic method is generally selected by the ANSYS. The tetrahedrons is just the method why we will use only tetrahedron shape to generate this whole pipe, and the hex dominant is the method why you will hex shapes to create this whole pipe, and so on and so on. Sweep method is just for the source and target. In our video, we will use this tetrahedron method. So select the tetrahedron method with the patch conforming. Patch conforming. Remember what I meant by patch conforming? Patch conforming means doesn't matter however the shape is tetrahedron, hexahedron, prism, or whatever that is, you have to maintain the given geometry shape. As in our case, is this pipe. That means the shape cannot change no matter of the given using element shape like tetrahedrons or whatever that is. So the patch conforming will ensure that I will get a pipe-like meshing. All right, now let's generate this meshing here. Generate this mesh here. The meshing is running, and meshing is done. And let's look at our meshing. So you can see this is a mesh of a pipe. So you can see as we had selected the tetrahedrons, every aspect of the pipe is selected by triangles. Every aspect is selected by triangles. If we had cut through this pipe, we could see tetrahedrons in the shapes. in this pipe actually. So next what we need to do is to, as I mentioned before, that tetrahedron, if we use tetrahedron shapes, the boundary would be very rough. We can see as well here the boundary is very rough. You can see. So I have to fix this by using inflation. Inflation is a method, as I explained in my previous video, inflation method is just the method where you have to fix the boundary. You have very concentration on the boundary, how the simulation will look like at the boundary layers. To do that, go to the meshing, insert, and inflation. And for this geometry part, select the whole body. Select the whole body. Make sure the body selected and is select all and apply. The five bodies is selected here. And for the boundary, this is the main part of this impression method. For the boundary, select this wall of this. So now see the body is selected. The body part, I do not want the body part right now because I have to fix the faces of this wall. So go to the face option and now select all of the faces outside of this pipe. So the faces, the first face will be this face. Now press Ctrl and to select the other face and this face, and finally Control this face. So all the four faces of the wall has been selected. Let's zoom it. So you know how to zoom as from design modeler. Here you go, and apply. Now change this transition ratio to 0.5 and this maximum layer number to 10. I will explain this, what are these layer and transition ratio later. Just let me generate the mesh first. Okay, the mesh is generating. 5% mesh has been done. Wait a bit. And our meshing is done. If I zoom it on this part, wait a bit. So you can see these layers. These are the boundary layers. Let's go to the inflation, and this see we have it has selected maximum layers as 10, and the face was the boundary faces, right? The red faces you are seeing, the red faces are was the boundary section, and this maximum layers number was 10. Now, if we look at the meshing, we will see there are 10 layers. There are 10 layers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 consecutive layers of the boundary that the meshing will take as the wall. So um, from here to here, from this part, the meshing will consider it as the wall. If I have increased the layer number, it would create more layers here. All right. So this was a layer, and what was the transition ratio? Transition ratio is basically the changing rate of a small triangle to bigger triangle. So just assume this, and let's generate the mesh. The mesh look like this. But the problem is the main flow will go through this face. So this face needs to be more finer than this wall. So the next work is to make this face and body meshing more finer. To do that, let's change the body sizing first. Insert, sizing, select the whole body. Make sure that this is selected, and select all and apply here. This is 5 body, and change this element size. Change this element size to, let's say, 0.04, 0.04, and generate. The meshing is generating, and the mesh is more finer. The body has more finer mesh than before. But our our main focus is the faces. Now we will choose the faces to have a more finer mesh. So click on the face option, go to meshing, right click, insert sizing. Now for selection, first you have to select all the 10 faces at the inlet side and the outlet side. To do that, go to this surface, go to make sure that the face option is selected. Now select this face and select all the other faces while making sure that you are pressing the control key in your keyboard. Select all of these 5 faces here as well carefully and apply. You should see 10 faces here. Now let's define the element size. The element size, let's take it 0.008 and generate. It's generating. Well, for more complex shapes, the meshing can also take 2 to 5 days. It depends on really the geometry. Our geometry here is very simple, thus it is taking just 10 or 15 seconds to generate these meshes. Anyhow, this is the meshing. This is the final mesh. Now you can see the mesh is very fine. Let's zoom it a bit. My bad. See, the mesh is very beautiful, very beautiful. So that you will see here 10 layers and the inlet are very small triangles, small tetrahedrons. So the meshing is done here. Now finally, what is important to know that you can also know the nodes and elements number. As I have mentioned earlier, the nodes number and elements number, uh, you can see that in here from statistics option. Go to the mesh and go to statistics. Expand this section and you can see the nodes number and elements number. Here you can see we have almost 84,351 nodes. That is a huge number of nodes, and elements is there's a very large number. Anyhow, so this is our mesh, and next we will do in the fluent section. What we will do, the simulation. Now we will solve the simulation in the fluent, and our meshing part is done. So now the save. Go to the file section. Go to save project as. Name it as your desired name. I am saving it as laminar pipe meshing and save.